Our motivation is to define a format that's easy and efficient to render in WebGL. We want engines to be fast by default. So rendering massive world terrain datasets requires visually accurate elevation for the entire globe. Since we are targeting mobile platforms through WebGL, we must render well on all target platforms. This includes desktop and mobile devices. To address these defined requirements for rendering massive terrain, we have created the open format quantized mesh. Of importance, this format supports triangulated, irregular networks. What this means is that we can place vertex data only where we need to. Flat terrain can be defined with fewer height posts. In processing the raw input terrain, we have a known geometric error tolerance for each level in the quad tree. We use this threshold to simplify the tile geometry at each level to ensure that we are defining the minimum geometry for maintaining a known geometric error. Finally, we've defined this open format with two goals in mind. We want these tiles to be both compact and require little effort on part of the client to hand the data off to the GPU. The terrain server uses the quantized mesh to define each terrain tile. On the server, we maintain a multi-resolution pyramid of tiles. This pyramid is multi-resolution as a result of mosaicing various levels of detailed input height maps. Let's shed some light on the quantized mesh format. This format leads with a quantized mesh header, followed by vertex data, which defines where the vertices are located in the mesh, index data, which defines how we draw the triangles for this mesh, followed by the edge indices, which is useful for determining where to draw the skirts on the tiles. In the quantized mesh header, we start by defining the center point of the tile, and this is useful for actually geolocating the individual vertex data in a tile. We then include minimum and maximum height. All height data is defined in the mesh is quantized, and the height data fits into this range defined by the minimum and maximum height, which is in meters. A bounding sphere is pre-computed on the server and can be used for frustum culling and picking, and that's in Earth-centered fixed coordinates in meters. Finally, we also define a horizon occlusion point. By doing horizon culling as well, instead of just view frustum culling, we reduce the number of tiles rendered by as much as 50% in common views. Quantized mesh provides a generalized solution for efficient transmission of pre-computed terrain tiles and is currently in open format and in use today. We believe that adding terrain to your applications shouldn't be difficult. Our terrain server provides an out-of-the-box solution that is designed to create and host high-resolution terrain for use in your geospatial applications.